This is Vivek Singhal, co-founder and data scientist at Cellstrat. We are an AI startup out of Bengaluru and Delhi. We work in the area of artificial intelligence, machine learning, and deep learning. We have this AI and machine learning series going on through webinars, and this is almost our 8th webinar. We record these webinars. They are available on our YouTube channel. So in case your friends have missed this, they can see this recorded webinar on our YouTube channel after the session. Okay. Let me get going here. Just some logistics issues, logistic notes. If you have any if you have any problem in hearing or seeing the screen, let me know. For any technical questions, we'll take the session. We'll take the questions in the end. I think I have the, okay. Just let me fix something here. I think I have the title wrong. To train ANS. So there, I just fixed the title. I think it was showing the last title we have presented. Okay, sorry about that. So as I was saying, if you have any problem in hearing or seeing the screen, just raise a hand on the chat and I'll try to address it. Otherwise, for technical questions, we'll take them up in the end. Okay. Let me just get started here. Okay. So just a plug on our startup Cellstrat. We are, an AI startup based in India, and we have some folks from US attending as well today. So welcome, friends. We are involved in, machine learning and deep learning application development as well as training programs. We do a lot of research. So our fundamental core is our research and content development activity in artificial intelligence and machine learning. We have probably one of the best content set in India in this regard. Okay. So let's just understand what is machine learning and deep learning. So machine learning, we in the old world tradition, analytics would rely on hard-coded rules, right? So the developer would have to hard-code the rules as for the traditional analytics. But in machine learning, the difference is it learns patterns based on sample data. So you have provided input and output, lots of such data samples, and it is able to learn patterns or insights from that data. Okay, and so this capability is called machine learning, and this basically enables artificial intelligence. So what is AI? AI is the act of making machines intelligent and make them do analysis just like the human brain does. So that's why we call it artificial intelligence, and it is enabled via the branch of AI called machine learning. Okay, and ML can learn from labeled data or unlabeled data. Labeled data would mean that you have provided input X, output Y. We call it supervised learning. It is able to derive a pattern between X and Y. And unlabeled data is when we have provided certain set of data with no corresponding output Y, but we are still asked to derive some insights from it, if you will. Okay. So unsupervised learning is a harder problem to solve. An example of an ML algorithm would be logistic regression. For example, in a pregnancy room, a doctor has to decide whether to recommend, normal delivery or cesarean delivery. A naive-based algorithm is used for detecting spam in email boxes. Okay. So let's go to the topic for today. Artificial neural networks. So artificial neural networks belong to the branch of deep learning. Deep learning is a more specialized or advanced form of machine learning, and the difference from machine learning in deep learning is that here we are dealing with lots of neurons, and each neuron, these circles you see in the image, they are acting like a classic brain neuron which exists in human brain. So after studying, the biological brain, the scientists realized that brain is able to do complex, decision making by where millions of these neurons are interoperating, and they are able to divide and conquer a complex problem like face recognition, speech recognition, analyzing text, or other kinds of complex problems. Okay. So instead of just one computation unit, I have many computation units, and these are called neurons, and they are interoperating to solve a complex problem. So that's what is an artificial neural network. Okay. Some examples of ANN. Google image search, Google Translate, which does language translation across 20 languages in real time. Facebook's Deep Face for tagging images automatically. Baidu's Deep Speech, which is able to handle voice queries in Mandarin, the Chinese language. And drug discovery, toxicity prediction in drugs, and so on. And mobile apps to detect skin cancer used by dermatologists or skin specialists. So there are lots of complex applications now being solved with deep learning and specifically artificial neural networks within the deep learning area. Okay. So as I was saying, this field is based on the concept of biological neurons. As you can see here, this is how a neuron looks like in the human brain. There are millions of these, as per the biologists in the human brain, and they interoperate to solve these complex problems. And we try to simulate the same concept in software through artificial neural networks. So this shows a ANN. So the blue dots, you can see these are all neurons. And from the left, an input signal comes, for example, an image. And the successive layers of neurons will process a little bit more of that image or add more value. And then the final output is produced towards the right. Okay. So in the right chart, you can see how this is working. It's a 4-layer neural network. The first layer of neurons is detecting edges in the image. The second layer of neurons is detecting features of the face. The third is concatenating the face. And the fourth one is basically doing face detection completely. So basically, it is divide and conquer. You can solve this kind of image processing problem with classic machine learning using regression and classification modules like decision trees or linear regression or polynomial regression, but it is very hard to solve using those classic machine learning techniques. So here the neural network comes handy, and by divide and conquer mechanism, the different layers of neuron are able to solve a very complex problem, for example, image face detection. So you can see another example of a neural network here. There are 2 hidden layers. Of each layer has three neurons each. There's an input layer and there's an output layer. And then the signal passes from input layer towards the hidden layers and finally to the output layer. So at each, when the signal passes, we are applying the signal by weight. So x1 into w1, the comma 1, plus x2 into w1, comma 2. That orange lines, that becomes h1. Okay, so h1 is equal to w1, comma 1 into x1 plus w1, comma 2 into x2. So this is how, so this is basically linear regression. If you have attended our linear regression seminar or webinar. So I am doing lots of little regressions here and summing up weighted inputs, and they are able to add little bit more value as the signal move upwards in this network. Okay. So now let's come to the main topic for today, which is how to train an artificial neural network. Now let me warn you something. So we are assuming you have attended our previous webinars and understand core machine learning, and you understand what is an artificial neural network at the fundamentally, and what is a perceptron, which was introduced in the last webinar. If you have not, then you might stay here, but it will be a bit hard to understand what's going on. So there is a prerequisite of attending this webinar that you should have gone through our other webinars. And this is an advanced topic. Deep learning and ANN is an advanced topic, and within that we are in training ANN, which is even more advanced topic. Okay. So there are 2 major algorithms for training neural networks. One is called Perceptron Training Rule or Perceptron Learning Rule, also called Rosenblatt's rule. It works well when training samples are linearly separable, and we'll see what that means shortly. And then update weights. We update weights based on error in the thresholded perceptron output. So we'll see that shortly. So I hope you understand what is a perceptron. If not, you can check our webinar on perceptron, our YouTube channel, after this session. And the second technique to train an artificial neural network is the Adaline rule, which uses gradient descent or the delta rule to minimize the cost function. And if you're familiar with the regression training model, you might remember gradient descent learning there as well. And it works well when training samples are not linearly separable. So perceptron rule only works for linearly separable data, and this one can work for not linearly separable data also. So we update weights based on errors in unthresholded linear combination. We'll just see in subsequent slides how this is working. Okay. So let me just move on there. So let's just quickly go through perceptron learning rule. I think we covered it last Thursday when we presented the perceptron, but we'll just have a quick revision. So perceptron is a very basic kind of neuron. Okay. If you remember from the last Thursday's webinar, and we initialize the weights to 0, and then for each training sample we compute the output value y and update the weights. So we just compare the expected output with the predicted output, and the difference is used to update the weights. So it's a concept of weight training to find ideal weights. Okay, let's see how weight training is working for perceptron learning rule. So you can see the weights are being adjusted at subsequent training steps. So let's say I run 100 training steps. In each training step of the whole neural network, I'll adjust the weights at every step. And the quantum of weight adjustment is provided by the difference of expected output y minus the predicted output y cap. Let's call it y cap. So y minus y cap multiplied by the input x, and then that eta is the learning rate. So that is a way to moderate the value of delta w. Okay, because we don't want a very large change in w suddenly. So we moderate the weight adjustment by multiplying with a fractional learning rate called eta, and that value is typically between 0 and 1. So it will be something like 0.1, 0.2 typically. It is found by hit and trial. There is no specific rule for the learning rate. Okay, it is also called a hyperparameter of a neural network. And then so delta w is nothing but eta into y minus y cap into hj. And if there are 3 weights to be adjusted, then there will be 3 different, there are 2 input parameter along with a bias parameter. So there will be 3 different weights corresponding to them which need to be adjusted as shown there in the bottom side, the bottom 3 equations. Okay. Now perceptron learning rule. So delta w, if you remember from perceptron, the output of perceptron can be +1 or -1. So if both of them, the expected output and the predicted output are both -1, then the delta w is 0. And if expected and predicted output both are 1, then again delta w is 0. That means weight need not be changed. It is able to produce the expected output. The predicted output matches the expected output, which means it has been trained now and no longer a weight adjustment is needed. But in case of wrong prediction, when the expected output is not matching the predicted output, then you'll find there is a difference. So 1 minus -1, so it becomes 2. So then there is a value of delta w by which the weight would be adjusted because the expected output is not matching the predicted output. Y is not equal to y cap. Okay, that's when the bottom 2 equations will work, and that means that the weight would be adjusted so that it tries to go in a direction where the expected output will start matching the predicted output. If you have any questions, you can just keep them handy or put them in chat window. We'll take them up in the end. Okay. Let me just see my dashboard here. Okay. Fine. So far so good. And all seem to be able to understand, which is great. Let me keep going here. So this is just a summary of the perceptron learning rule. So just to summarize, we are running multiple passes of the neural network. In this case, just one neuron, which is also called a perceptron. And in each pass or each learning loop, we will adjust the weights W1 and W2 as shown in the diagram on the right. And each of the weights will be adjusted by the component called delta W. And the value of delta W is computed by multiplying the difference between expected output target T and actual output O, T minus O into X, the input value, and multiplied by a learning factor eta. Okay. So eta is there to try to moderate the weight adjustment process or not allow a large value of weight adjustment. So if it is a fraction, since eta is a fraction, that delta W will always be a small value. We don't want abrupt weight change. So we try to keep the weight change low at a particular step. Okay, so that was perceptron learning rule. Now let's look at what is linearly separable. So as I was saying, perceptron learning rule works when the data is linearly separable. You can draw a straight line between two classes of data. I mean, this is a classification problem, I guess. And then if it is non-linearly separable data, as shown in the middle, graphic, you find there is no straight line which will satisfy the classifier. So in the two right charts, we can't find a straight line which classifies the two kinds of input. So we have a problem. The perceptron learning rule will not work for the right two charts. Okay. What do we do in this case? So this can be solved with the Adeline rule, which can also solve the not linearly separable data. Okay. So this is just to summarize perceptron training rule. We take weighted inputs, and we add a bias x0, which is 1. We multiply all of these inputs by weights. We sum them up, w0 into x0 plus w1 into x1 plus w2 into x2 and so on. We apply a step function. This is classic perceptron. If you remember, this is a classic perceptron model. And step function means if that summation of wx is greater than 0, then output 1. If it is less than 0, then output -1. Then we compare the expected output with the predicted output, and we propagate that error back and adjust the weight in the next training pass. Okay, this is, so we run this loop, let's say thousands of times, till the weights start, the predicted output starts matching the expected output, and that point I have found my ideal weights, and I have a trained model. Okay, so this is a summary of the perceptron learning rule. Now let's start looking at Adeline rule. Okay, I'll go relatively fast. I have a lot of content to cover. I'd like to demo a small program to you as well. Okay, so what is Adeline rule? It is useful for non-linearly separable data also. It is also called Widrow-Hoffe rule after the scientist who found that. And in this case, let's see the diagram of this rule in the next slide that will help us. So you can see the bottom diagram indicates the Adeline or adaptive linear neuron rule. So here I have introduced this activation function, so which is nothing but a linear function. Okay. The idea is that this becomes differentiable. So I can differentiate I cannot differentiate that sign function, the threshold function shown there, which is outputting just +1 or -1, as in a perceptron. But a linear function, the activation function, which is shown in the red, that becomes a differentiable function. So if you know basic differential calculus, and we will understand in a few slides why we need a differential function there. But the main difference is there is a linear activation function introduced, which is differentiable. We can run a derivative on it or differential calculus operator on it, and we adjust the weights with the output of that function. Okay, and finally we still apply the step function in the Adeline rule to output a classifier of yay or nay, or -1 or +1. Okay, so you can see in those two diagrams the main difference between the perceptron rule and the Adeline rule. Okay, how to train a basic neuron or artificial neural network. So what we are trying to do here, so we have already said in case of perceptron rule, we were calculating y minus y cap. In this case, we are calculating something called a loss or a cost function for the Adeline rule, and that value is defined by y minus y cap square. So y minus y dash square. So I'm taking a difference of the expected output and the predicted output. So same concept as perceptron rule, but in this case I'm squaring it. I'm summing it for different values, different input values, and then I'm dividing by 1/2, 1/2. Okay. So this is called sum of squared error. We also call it root mean square error. So the idea is to now minimize this cost function or loss function, as we call it. So what will happen if I minimize this loss function? Y will start approaching that y cap or phi of zi. So when y starts approaching y cap, that means the value will become infinitesimally small or close to 0. That means the expected output is now starting to match the predicted output, which means the loss would be, 0. Okay. So this is exactly what I'm doing here now. I'm trying to bring y close to y cap. Same as perceptron learning rule, but in this case, I'm squaring it and dividing by half. Okay, so we'll see how this works in the next slide, or how it helps. So let's plot the loss or the cost function JW. Just let me go back. What is JW? That is that term shown there. That is the loss function. Okay. Just a moment here. Somebody has a question. Okay. Okay. Question came: why to divide by 1 by 2? So 1 by 2 is not so significant. Okay. Uh, I divide it so that I can, once I take a differential, that the square 2 will come on the left and 2 by 2 will get cancelled out. So it's not significant. It's just something we have decided so that we can cancel out the 2 of the square, which will come on the left after I take a derivative of that term. So we'll see that on the next slide. Just wait a moment. So that JW, the cost function, let's plot it against the weights. So W is the weight and JW is the cost or loss function, which we showed you on the previous slide. So it so happens that this curvature is convex. So it is shaped like a parabola like this, okay, a reverse parabola. And when I'm trying to say that I'm trying to minimize the loss function, in a sense, I'm trying to arrive at the minimum value of JW, right? JW is the loss function or the cost function. Either term can be used, loss function or cost function. Both are equivalent. And there JW is that function, and I'm trying to achieve its minimum value. We call it the global minimum. As you can see, the global cost minimum represented by J min of W, and we are adjusting the weights so that it will reach the lowest point of the loss or the cost function, as you can see in that chart. So this slope is called gradient, okay, and I'm descending this gradient or the slope. So that's why I call this rule the gradient descent algorithm. Okay. So by tiny adjustment in the weight W, I am going down the slope of the loss curve, and I want to end up at a bottom point where the loss is minimized. Loss cannot become zero, unfortunately, in this case, in most cases, in fact, but this is okay. We'll get to a minimum possible loss at least. Okay. So if you see that chart, that explains what I'm doing. Okay. Let's keep going here. So now the same rule. Now, as we saw in the previous chart, we want to adjust the weight by teeny mini changes, so that I go down the gradient, so that I can arrive at the minimum loss point. And in this case, the delta W is indicated to be, eta learning rate into the differential of the loss function. Okay. So unlike doing y minus y dash, which I did in perceptron learning rule, I am taking a derivative or the differential of the loss JW. And the third equation shows you dj over dw. If you want to take a derivative of it, we can prove mathematically that it leads to this value, y minus y cap into xi and summation over it, and with a negative sign. So why with a negative sign? So the negative over into minus eta will become positive, right? Negative into negative will become positive. So that's how it is. So basically, I'm able to cancel out the negative, and so delta W is now that value minus eta into dj over dw, and you substitute that, you get the weight adjustment logic. So in each pass of the training loop, I'll be adjusting the weight by a tiny value represented by delta W, which in turn can be expanded by that second last equation there. Okay. And what that equation is, eta into summation of y minus y cap into xi. Y is the expected output, y cap or phi of z is the predicted output, and xj is the input, of course, and I'm taking sum over all input values, and I'm multiplying by the learning rate, learning factor eta, to moderate the weight change and not allow a large weight change to happen. Okay, I hope it's clear. So now, interestingly, you'll find that the Adalin rule and the perceptron rule both look similar. Let me just go back. So delta W in case of perceptron rule was also, eta into y minus y cap into xj, right? So interestingly, they look similar, but the difference is here I am taking a derivative of the loss function. There I was simply subtracting y minus y cap. Okay, so that is the difference. So I'm operating a derivative over a continuous function, that activation function we saw in the diagram. And whereas in case of the perceptron learning rule, there was no differentiable function. We were just taking y minus y cap because we just had a sine function, which would produce +1 or -1 as output. Okay. So now the weight update is calculated based on all samples in the training set. So let's say I had 1000 or 1 million samples. I would run through all of them before the weight adjustment would happen. So this is called batch gradient descent, as opposed to something called stochastic or incremental gradient descent, where I will update the weight after processing individual data samples. So I'll process 1 million data samples one at a time through the network, and I would be updating weights after each sample being processed. That is called incremental gradient descent as opposed to batch gradient descent. Okay. Okay. So yes, so somebody is saying that they are not able to understand, and it is understandable. As I announced in the beginning, that this is an advanced topic. We are in deep learning. So if you are not familiar with core machine learning and introduction to neural networks as presented in our previous webinars, this will be hard for you. And I suggest you attend our previous webinars on our YouTube channel. The link will be provided on our meetup page after this session. Okay, let me keep going here. So interestingly, Adalian rule is very similar to the logistic regression rule. Okay, it's very similar. So the difference being that the activation and cost function is similar, is different. Logistic regression was a classification algorithm we presented as part of core machine learning. So whereas Adalian rule is used for neural networks or deep learning environments. Okay. Okay, let me just keep going. Tuning learning rate. So we discussed the concept of learning rate eta, which is very important hyperparameter as we call it. And there's another hyperparameter called number of epochs, n underscore iterate, and underscore iter, which indicates the number of training passes. So typically I could be running tens of thousands of training passes. That's why these deep learning training models will take hours or days to run in some cases. I mean, normally half an hour to few hours is pretty normal to learn a decent sized deep learning application. Okay. With GPUs and cloud computing, they are trying to optimize that, but still it takes long time for larger applications. So let's look at the role of the learning rate. So you can see two situations here. If I keep learning rate as 0.01, which is a small value, then you can see that the error is not reducing, it is increasing. So with 0.01 learning rate, I'm not able to arrive at a minimum error point. It is escalating the error with number of training passes increasing. Epochs refers to the number of training passes, right? So epoch is just a term for a training pass of the neural network, a training step of the neural network. So as I am doing more and more training steps, the sum of squared errors in the left chart is actually increasing, which is a problem. I want the sum of squared errors, or JW, or the loss function as I called it, to decrease, not increase. So the right chart is better. So learning rate is given very tiny value of 0.0001, and then we find that the error is able to reduce, and we will arrive at a global minimum point for error. Okay. So in this case, a better learning rate is 0.0001. 0.01 will not make it converge to the global minimum, and it won't work. Okay. So as you can see, again, in a different way. So if I am using a small, an optimal learning rate eta, then in the left chart I am able to slowly arrive at the global cost minimum. But if I use a large learning rate, you can see in the right diagram what will happen. It will miss the global minimum. It will keep bouncing back and forth like a pendulum, if you will, and it will go left to right, but it will not stop or land at the lowest point of JW loss function. So you have to keep, now if you keep the learning rate way too small, then it will take long time to arrive at global minimum. If you keep it large, it will not reach the global minimum. It will bounce left and right like a pendulum. So you have to find somewhere in between a learning rate, which in a reasonable time frame is able to find you the global cost minimum. Okay. So this is one more diagram for the same thing. So I can use this kind of gradient descent for linear regression as well as for Adeline rule. So I wanted to find a line fit in the left chart for those dots. And again, I'm trying to minimize the mean square error or the loss of the cost function. As I told you, it can be called sum of squared errors or mean square error. And I want to arrive at that dot point where the minimum loss is found. At that point, my ideal weights exist, which in this case is W1 equal to 1.5, because that is the point where loss gets minimized. Okay. Now, there's a question of how do we find optimal learning rate? So that comes via experience. So you try typically with 0.1, 0.01, 0.001, and if the model is too slow, you'll have to increase the learning rate. But if you are not, it is not converging to an error minimum and the loop is going on and on, unable to find the optimum bits, then you have to reduce the learning rate because you could be missing the global minimum. You could be swinging like a pendulum. So this comes by experience, hit and trial, but typically 0.1 to 0.01, 0.001 are some values which data scientists try. So some, subject matter expertise is required, experience is required to find, but yeah, you have to do hit and trial. Okay. So this is just a summary of gradient descent algorithm. What I did here, I initialized each weight to some initial small random value in the beginning. Then I adjust the weights, with delta W being added to the weights, and I am adjusting the weights by that term, eta into t minus o into xi. T is the target output, o is the observed output. Okay, so we have already reviewed this. Okay, so that's it for the theory part. Now let me present you a tutorial that will make it a lot more fun. Okay, let me start my Jupyter notebook. Today we'll be looking at a Jupyter notebook program. Jupyter notebook is a very intuitive, uh, IDE or integrated development environment for developing Python programs for, uh, let me just, for machine learning and deep learning. Let me just go there where I need to go. Okay. So this is how you basically first I change to the directory where I want to start my Jupyter notebook server. I'm running it on my laptop, so we can still run small machine learning program, deep learning programs, but for very large programs, it will most likely conk out and it won't be able to handle large scale machine deep learning here. For that, you'll have to go to AWS cloud or Google cloud or one of those. So this is how you start a Jupyter notebook, the way I'm doing it here. Okay. You have to install this and then you just trigger Jupyter notebook. It opens a web session. And within the browser environment, you'll see an IDE for, now let me go to my event for today. So I can see a Windows folder kind of structure. So you can see a different webinars there. Hopefully the font is good enough to understand that. So I come to today's webinar. Okay. I'm going to go to the tutorial for today. So hopefully the font is good enough for you. Okay. I hope you can understand the font. So this is a complex program for demonstrating, how to train artificial neural networks from scratch. And here we are using low-level Python code. We are not using a higher-level library as in Google TensorFlow or other kinds of APIs yet. Okay. We'll demonstrate building a multi-layer ANN to classify MNIST digits. Okay. What are MNIST digits? Let me just Google it for you. So this is a standard data set available on the internet, all right? So this is published by US Department of Standards something, And you can see here that this is it has 70,000 handwritten digits, and there is also a digital label corresponding to each of these digits. Okay, so there is an image of a digit, handwritten digit. There is also a digital label. So input X is the image of the digit, and output Y is the digital label saying this is a 0 or 1 or 2 or 3 or whatever. So the digital output, the label can have 10 possible values, a value ranging from 0 to 9, right? So again, I'll repeat, what is input X? It's the image of the handwritten digit. Output Y is the digital label which says what value is contained in that image. Okay. So we'll feed these 70,000 images into our neural network model, an ANN model, and we'll try to develop a classifier which is able to train and recognize handwritten digits after this training. Okay. So now you understood what is MNIST dataset. This is based on a particular chapter from the Sebastian Rasta book, very one of the best books. In case you want to know what are the best books, so let's start running this code. The beauty of this IDE, we are all used to Eclipse or Spider or Atom or PyCharm for Python development or Java development. This is a slightly different kind of IDE. It does the same thing, but in a very intuitive fashion. You can run this, block by block. These are called cells. So these different things which are highlighted are called cells. So let's run this first cell. It automatically progresses to the next cell. You can intersperse it with textual material also. It won't cause any harm. You can see I'm just running the Jupyter notebook. It is based on IPython, which is a form of Python. So I'm running. So we have already seen this kind of diagram, right? For a single perceptron using Adeline training rule. Okay, there's an activation function right there, which allows differential or derivative capability to me over the loss function. So let me keep going here. So this is a multi-layer neural network. So there's a hidden layer also here now. Okay, so there are input neurons. There's a hidden layer neurons and there are output neurons. And finally, I want to find a classifier given any input X image. Okay. So this is another view. You can see here that I'm adding a bias. I'm adding this bias here. Okay. Now let's do forward propagation. What does forward propagation mean? Means that I am passing the signal from left to right. Okay, that's what forward propagation means. In neural network, there is a concept of back propagation, which we'll discuss probably in the next webinar. That's how weights are adjusted, but today we won't be discussing that. So this is something called sigmoid function. So instead of a step activation function outputting 1 or plus 1 or minus 1, I want to output a probability between 0 and 1. So given any output Z, it is able to convert it into a probability, a value between 0 and 1. And typically, if it is probability is more than 0.5, we mark the final output as 1. If the probability is less than 0.5, we mark the final output as 0. Okay. So this is just explaining how to extract the MNIST database from internet. And this piece of code is just loading the MNIST data set into my memory here. I'm not going to explain every command on this program. It's a very large and complex Python program. We'll just use it to understand or demonstrate the concept of training artificial neural networks. So we can just suffix it to say here that this function is loading the MNIST dataset into memory. Okay. So I'm just seeing what is there stored on that hard disk in that folder by doing ls command. If you're familiar with Linux or Unix commands, ls means list. So here I'm unzipping in this block. I unzip the MNIST zip file. Okay. And then in this cell, the one which is highlighted, the blue cell, I am loading the training data set out of MNIST. So I told you in the beginning, MNIST is a 70,000 images dataset, and I am going to load just 55,000, which are classified as the training data. So XTrain would be a vector of all the images which have handwritten digits for 55,000 such images, and YTrain would be 55,000 corresponding digital labels for all those images. Okay, so each of these would be a vector of images, and the YTrain would be a vector of digital labels, and the number of units in that vector would be 55,000. Because I told you, out of 70,000, 55,000 are kept for training step, and 15,000 are kept for the testing step to verify the accuracy of my trained model. Okay. Okay. Well, in this case, we are saying, yeah. So in this case, the split is not 55,000, 15,000. It is 60,000 and 10,000. So 60,000 out of 70,000 are kept for training step, and 10,000 are kept for test step. So the test data is loaded in X test and Y test. So X test is the 10,000 images. Y test are the corresponding 10,000 labels. Okay. Let me see if there's any. Well, can I get this notebook? Will this code be available to us? Yeah, I suggest you just do a Google on Sebastian Raska GitHub. GitHub is the open source environment where most of these publishers and authors will store their codes and tutorials. You can download this from the GitHub environment of the author Sebastian Raska. Okay, so you can get all these programs on the internet, download them, and run them on your own environment as well. Okay, now what we are doing, we are just printing the 9, different 10 different label here, just for to view how they look. So these are just some random sampling I'm doing here out of 60,000 images. Okay, and then I'm also doing a sampling of, I want to extract 25, actually I want to extract 25 images of the letter 7. So it just finds the first 25 images of the letter 7. I'm printing them out here just for fun, no specific agenda so far. Okay, and then let's see what we are doing next. So we load the MNIST dataset. Okay, we print its shape for the training set. It shows as 60,784. What is 784? 784 is the flattened array. What I do, I take each image pixel, and what is each image? Each image is a 28 by 28 image, right? So what is 28? 28 pixel. So you see each of these images, the specific image, can be represented as a 28 by 28 pixel matrix. So if you multiply 28 by 28, the result comes out as 784. That's where this 784 comes up. I flatten each image into one dimensional vector of 784 pixels. So instead of having a two-dimensional image, I flatten all the pixels into a one-dimensional vector. And since this was 28 by 28 was the dimension, it becomes 784 contiguous pixels in a one-dimensional array. Okay. So let's see what I do next. So there's some error here. I might have missed some step. Let me just go to the first and try to execute again. I think I might have missed some cell, and because of that it errored out or something. Didn't find that variable declared. Yeah, so it will take a long time to run this, because the problem is I am processing 60,000 images, if you remember, right? So you can see it printed 60,000 images. Now I'm going to implement a neural net MLP. So I define a multi-layer perceptron or a 3-layer neural network. Okay, and I'm using low-level Python code to do that. I'm not going to use TensorFlow high-level API, which will make it easier. You just want to understand it at a lower level. I'm not going to try to explain you this complex code, but just understand this is creating a model for a multi-layer neural network. Okay, setting up the one hot vector, sigmoid activation function, the forward propagation loop, compute cost, which is cost computation using gradient descent kind of formula, then a predict function to predict for test output. Fit is to find ideal weights. So fit in machine learning, the word fit is used for the process of finding ideal weights. And predict is the word used for predicting the output with a trained model. Okay, that is the difference between fit and predict. Standard words used in machine learning. So I defined the model there of the multi-layer and neural multi-layer perceptron. Then I'm going to run 10 passes of the training loop. So initially this tutorial had 200 passes, but just to make it run on my laptop and not take it hours to run, I am reducing the number of training steps to 10 or n epochs 10. Okay. So I call that neural network model. Okay. This is what we did here. We did a fit here. Fit would mean find the ideal weights. Now in this case, I'm using 55,000 only, and you can see it is adjusting the values of training versus validation accuracy, and it is showing me the cost. And on the left, you can see the number of training passes which are running. So currently it is training. It is running 10 different passes. On the left, it shows 9 of 10. So 9 steps of training have been done. Now all 10 have been done. So you can see it was printing the training loops as they were progressing. It shows the final cost. So training accuracy is at 93% after 10 passes of the multi-layer perceptron, and validation accuracy is 94.96%. Pretty decent. It will work for example, situations which are non-mission critical or non-life threatening, for example, e-commerce product recommendation, but it will not work for healthcare applications or driverless cars. If you are only 94% accurate in healthcare or driverless cars, somebody is likely to die. So that's what this means. So in those situations, we like to achieve 99.9999% accuracy before regulators will approve those kind of applications. Okay. Now this is just some sample code. So here I am plotting the cost versus epochs. So you can see the cost is going down as we run 10 different. So you can see on the x-axis there are 10 different, epochs or training loops which I ran, and then the cost was going down, which is good. So I'm slowly trying to arrive at the minimum cost or the global error minima point. Okay. And now I'm printing the accuracy for training data and validation data. So you can see that training and both training and validation accuracy improve as we go from left to right on number of epochs, right? So as I run more training loops, it finds better and better weights, and the accuracy of the model keeps increasing. And then I am predicting, the accuracy at the bottom here. I'm predicting the accuracy of the test data set. You remember 10,000 word test data set. So I'm predicting the accuracy here, and it is coming out as 93%. So as I said, this is good enough for, let's say, e-commerce product recommendation. If you sell a wrong t-shirt, no harm caused, but you can't do wrong healthcare. You can't do error in driverless cars. Somebody will die, right? So it depends on the application, how accurate the model has to be. So there are various ways you can tune the accuracy. In one of the subsequent webinars, we'll be doing an advanced session on how to train a neural network for better accuracy. So these are complicated topics. If you are new to machine learning and deep learning, you can't suddenly understand all this. This is assuming that you understand core machine learning, you understand the introduction of basic neural network, and that's when you have arrived here. Now what I'm going to do here, I'm going to take 25 such images, and I'll find 25 such images where the machine learning perceptron or the neural network is not able to predict the correct label or the correct output. Okay, so I'm going to find 25 error images where the error is happening after training it. So I told you it's 93% accurate, right? So there are still some images where it makes error. So I'm going to try to find those 25 such images where it makes an error. Okay, let's see what happens. So we just find where the error, the output does not match the predicted output. Okay, where the expected output, you can see here, y test does not match the test predicted output. So those are the kind of points I want to find. I want to find 25 such points. So you can see here, these are the images where it failed to predict the correct output. So T value on top of that shows the target or the known label for that image. The P value shows the predicted value. So it's very interesting if you study this carefully. The very first image shows a 5 and the digital label says it should be 5, but your model is predicting value 6 because it looks kind of like 6, so it gets confused, right? And again, next one, it is expecting a 4, the target output 4, but the predicted value is 6. In the next one, it is expecting a target output of 2, but it predicts a 3. So as I said, we are only 93% accurate. These are 25 images from that set where it could not find the correct, it is unable to predict the correct value based on the trained model. Okay, so very interesting analysis here. I think that should be about it. And this is just showing the weight matrix across, 2 layers of the neural network. So this is showing something called back propagation, which we'll take in a subsequent webinar session. And this image just shows us the fact that we are trying to arrive at the global cost minimum on the loss function matrix, on the loss function graph, right? So that's about it, folks, for today. I hope that was fun and you could understand it. We are open to questions now. If you have any questions, you can ask them in the chat window. Before we go on, let me just announce something here. We are planning to start a new kind of training program. Okay, so I'll tell you the challenge. So this is off topic now slightly. We are a small AI startup and we have a lot of projects going on both for training and consulting in artificial intelligence, machine learning, and deep learning. The problem the market faces today in this very promising area of AI is there is not enough trained experts available. So there are training companies like SimplyLearn or others, Triple IT, which provide certification programs. But we are still finding a very critical shortage of expert people who are expert in machine learning and deep learning. And we ourselves need more such resources. So we are planning to launch a training program, a certificate program, and we are calling it Machine Learning Expert Series. Okay, we'll launch it in April sometime, and it is not just something you pay and you can get into. It is a different kind of program. While there's a payment involved, and we'll be teaching that through webinars and hands-on projects, but we'll be interviewing people for that. So the entry will be only by interview because we need to use these resources for our projects and training projects and consulting projects. And as well as we get a lot of demand from other companies looking for trained AI experts. So our program will start sometime in April. It's not yet on the website. You can contact us through our contacts on Meetup page if you're interested. It's a paid program. It will involve highly intensive personalized coaching by me and my data scientist colleagues in Cellstrat, and we'll be giving certificates only, but it will be only by selection. We'll be taking the rigorous interview to select people who get selected in this, even though there's a payment required. Okay, and then we'll spend time with those resources every week to make them experts in machine learning and deep learning. We are calling it Machine Learning Expert Series. Just a prelude. It's not yet announced on our website, but I just wanted to announce that here. In case any of you are interested, then you can contact us and we will have to talk to you and see if you are able to, if you are the right fit for that, because it may not fit everybody. If you are new to machine learning or deep learning, it will be difficult. So we need people who already have groomed themselves in this area to some extent, who are very strong technically and in algorithmic design. Okay, so it will be by selection. It will be an intense coaching experience. We want to groom 10, 20, 30 people who can go out and do more projects in ML and help us and other companies in training and consulting. Okay. If you have any questions on this session today, kindly ask them now. I do see some questions. Let me see. So somebody is asking webinar of previous series of YouTube link. Yes, so you can find it on the our webinar page on the meetup page. After this webinar is over, we'll put a link to our YouTube channel or on our meetup page. You can go from there. Any other question? You can ask them now. So we have like another 2 minutes before we can close this session. So if you have any questions, you can ask them now. Any technical questions? Okay, so there is a question. If you see our YouTube channel, what is the order in which to watch the previous webinars? Okay, so the answer is, I know we didn't mark it as first, second, third, and so on. The date is the best indicator. Just see the date when the webinar was posted on the YouTube channel, and just go by date in chronological order, and you'll find the right series. Because so far we are maintaining the series as per the date. So the next session is always the next version or more advanced than the previous one. Okay. Okay, well, there is a question. I come from software testing background. How do I get into machine learning and AI? Okay, so good question. So normally, yes, for very technical data scientists, it has to be for folks who have some programming background, but even IT testing or project management folks who have done some programming, maybe at college level or later part of their career, can aspire to it. They just have to do basics of Python course from somewhere. If they are able to do basics of Python course, and also they have to revise some of their high school algebra, linear algebra and calculus, so that they can understand the algorithmic equations here, and they'll be able to take a lot of these courses and become a data scientist in AI and machine learning space. So is it required to know Spring? What are the skills required to enter into AI? See, basically, this is all mathematical algorithms, and most popular language here is Python. Okay, so I recommended that you take a small Python course on websites like Coursera or Udacity or other sites. And if you have some programming background, you will understand Python code pretty easily because it looks very similar to Java or C or C++, if you will. Yeah. If you don't have any programming background, then you have to properly go through a basic Python course. Then only you'll be able to do these programs. But you can still become a functional data scientist. What do I mean by that? You can still learn the algorithms like regression, decision tree, support vector machine, neural network. You could still be a product manager in this space. You could still be a project manager in this space or a marketing manager in this space by understanding the algorithm. You don't have, or not everybody has to be a developer, right? There are other functions in an AI company or AI group. Okay. Okay. Next question is any book or online resource you will recommend? Okay. So I told you, you can write these names: Geron, Geron, and Rashka, Raschka, Geronras. Okay, I'll just maybe mention them here. I'm just typing these names out. Okay, so I put that as a message in the message box, so you can see Rashka and Geron are some of the best books for learning machine learning and deep learning. Okay, and then you can do Coursera courses. Simply Learn has one of the best programs in machine learning and deep learning in India. And as I said, we'll be launching our own expert series program, but that will be only for select people by selection. It won't be open to all. Simply Learn, interestingly, has one of the best programs, and disclaimer, I made that course for them. I mean, we in Salesstrat have made Simply Learn machine learning and deep learning courses, so highly recommended. Excellent content there, and that is taught by very good instructors, which Simply Learn has. Okay. Is R an alternate for Python? So R is a good alternate. So folks who have traditional statistical programming background have often been in the world of R or SAS, IBM, SPSS in some cases. In machine learning and deep learning, Python seems to have taken the lead. primarily because companies like Google and its product called TensorFlow for deep learning, they are pushing Python. Okay, but you can do in R, but I would recommend Python because you'll find more of the libraries now in Python. So switching from R to Python or Java to Python is pretty easy. If you understand one language very easily, you can pick up the other language. Okay, the syntax looks quite similar. Is it must to understand the mathematical equations? See, unless you are a pure sales or CEO kind of person. Okay, so machine learning and AI is all about algorithms, right? And algos are all mathematical in nature. So if you are a senior management person or you are a sales and marketing person in a company or maybe just a non-technical project manager, then you don't have to understand the algos. But for technical product managers, technical program managers, software testing teams, QA teams, they have to understand algos. So you have to revise your very basic. You don't have to master your high school maths, but you have to revise basic, vector matrix, linear equation, polynomial equation, and differential and integral operator. Very basic level. That should be sufficient. And most of us have done maths in high school. So once you pick up your bit of maths book or just Google, there are a lot of sites, it will come right back to you because you would have done it in high school. And I know we haven't used maths in our careers, but now it's time to get back to that a little bit. Okay. I read some article that ML heralds selenium. That means after some years there won't be automation testing. So I didn't understand, but I think you're trying to say DevOps automation, with Selenium has been a very popular quality assurance testing tool for the QA and testing groups. I am familiar with that. Uh, Now Selenium also, I believe, is introducing machine learning the way it does automated testing. So there will be testing always. Okay, we always will have to do testing, not that testing will become redundant. It will be automated using machine learning, and tools like Selenium and others are also now upgrading themselves to adopt machine learning for testing. So there'll still be people who will have to program the ML models for testing, but not doing directly running the test cases, if you will. Okay. Will there be any requirement to tune the equations? I mean, yes. So you have to see these equations are defined by leading scientists. So we use them, but sometimes we may have to change them a little bit. But mostly you can use the existing algorithms as defined by the global leading scientists and available in these popular books, right? So R language is all right if you prefer R. Over time, if you are going to spend good amount of time in machine learning, deep learning, my recommendation is switch to Python, because most of the upcoming stuff is happening in Python, and TensorFlow, out of all the deep learning libraries, TensorFlow has taken lead, which is Google product originally, now open source. MXNet from Amazon, and also from Facebook, and PyTorch from Facebook, and these are some other deep learning libraries. But Google TensorFlow seems to have taken the lead. It seems. Spark ML is also there from Apache Foundation, but TensorFlow seems to be leading now. Okay, your program in April for deep programming are also targeted for project manager functional aspect. So our intensive machine learning program is only targeted for technical people. Folks will be able to do these Python projects, so not suitable for non-programming resources. Okay, for non for people who are not programming, as I said, Simplilearn has some excellent program, and you can also do long-term courses like an MSc or a triple IT kind of program. Any other questions? This is a good time. Otherwise, we'll have to close it. It's 7 minutes over. Okay, I think that's about it. Thanks all for attending.